Hello, welcome to my channel Code Design. Today I will be discussing how to design a parking lot, and we will implement a parking lot based on some assumptions. The implementation is already there. I will go through out the implementation. So now when we talk about parking lot, basically some questions comes into mind. Is it a lot or is it a parking garage with multiple levels? If it is a lot, then the requirement will be a little bit different than having a multiple levels of parking garage. In our case, we have considered it a multi-level parking lot, not a single lot. If it is a single lot, then we can actually have some scenario like the entries, which entries are closer to the spot and assign a spot that is closer to one of the entries. But since we will be using a multi-level lot, basically we will be assigning from the ground floor and then first floor, second floor, and so on. So the first floor or ground floor should be considered the closest one. So let's look at the assumptions that we have. Here are some assumptions. What type of vehicles should we support? We can support like motorcycle, car, and buses. Does the parking lot have multiple levels? Yes, the parking lot have multiple levels, and this is the layout of the parking lot that I'm considering. A layout for a single level. So if you see, it's level one, and it has large L for large spot, C for compact, and M for motorcycle spot. So basically, we will be using three type of spot. It's a motorcycle spot, compact spot, and large spot. Does each vehicle type take up a different amount of parking spots? Like a bus, to fit a bus, we here we are saying that we'll need five consecutive large spots. What's consecutive large spots? That means it should be in a row. If different row, then they cannot be consecutive, right? A bus cannot fit in different row since we are considering this thing. So this is the layout for our level, and another spot uses motorcycle spot can fit motorcycle, compact spot can fit motorcycle and car, and large spot can fit everything motorcycle, car, and buses. So here are some use cases. What we'll be considering. We should be able to configure spot layout for all the parking levels in config file. We should be able to park a vehicle and get ticket if spot available. During checkout, spot should be freed. Amount due should be printed along with other info in the ticket. So this is the basic things that we will be going to implement. Now let's go to the diagram. To understand better, we need a class diagram for better understanding. So this is our class diagram. Before we jump onto the code, we'll need to understand what are the entities that we are going to use, and what is their relationship. Then it will be easier to follow the code. Let's start from parking lot. So parking lot, as I said, we are considering having multiple levels, different level of parking lot, level 1, level 2, and each level will have spots. These are the spots. This is the spot class, and what type of spot? Spot is using a enum. So we have spot like motorcycle spot, we have compact spot, and we have large spot. So motorcycle spot will fit motorcycle, compact spot can fit car and motorcycle, and large spot can fit everything. And if we look at the spot, what we have in spot, we have a spot ID, we have a spot type, we have vehicle. If a vehicle is assigned to this spot, we will have the vehicle reference here. and is occupied if a spot is occupied. And there are some functions like reserve spot. So given a vehicle and a start time and a duration, if someone wants to reserve it for certain duration, then we can reserve a spot. We can free a spot during checkout, and we can get a spot by spot ID. So this is our spot. And level, so level, each level has lots of spots, and num rows, right? Level has rows because as we said that we are considering that there will be rows, and each of the vehicle will be in rows. And we have a row list here. So is basically the list of spots. So each list of spot is a row, and this list of spot is basically all the rows in a level. So there are some functions here also, like add a spot. When we configure the parking lot, we need to add a spot to level, right? So we can call this add a spot, provide a row, which row in a level will be added, and then pass this spot. So this spot will be added in this level. We can assign spots, we can find available spots, we can create spots for level, that is for also um, when we want to create all these spots for a level. And is consecutive free spots exists. Why we need consecutive free spots? Like bus, I have mentioned that a bus can take up to 5 consecutive spot, or bus needs 5 consecutive spot. So we need to check that in a row if there are 5 consecutive spot. And this is print layout for level. So this will print out the spots arrangement in a level. So parking lot is our main class. What that parking lot is does consist. So parking lot has a parking lot ID. So that means we can actually create multiple instances of this parking lot. So if it is a parking garage, like if you think of parking garages of Newport Mall, it's a big mall in Jersey City, and it has like North Garage, South Garage, uh, uh, right? So different garage, right? So and these are multi-level building. So if we create object of parking lot, we actually can create like one for North Garage, one for South Garage, and each of the lot will have their own levels, own spots, and everything. So this is scalable for having multiple building and managing them. Just we need to create a object of parking lot with a name on it, or with a. So so what we have in parking lot create level. We can create levels. We can add new level. We can park a vehicle. We can assign ticket. So basically, assign ticket will call park vehicle internally, and if the vehicle parking is successful, then it will assign the ticket, print the ticket. And this is checkout vehicle. So once we are done and we want to check out, providing the ticket ID or ticket number, we can find out the spots and free the spots and calculate the amount for parking. Those kind of things we can do. And parking ticket here, what we have in parking ticket, we have here ticket number, we have vehicle associated with this ticket, we have spots, right? So we can have multiple spots on a parking ticket because as I said, that a vehicle can take up to more than one spot. And start time initially will be assigned, end time will be null initially. Or during checkout, we will find the end time, then the amount calculation for amount will be there, is paid, and amount. So what are the functions there? Parking duration in minutes, calculate amount, set end time, and print ticket. So now this inheritance is some of the people will not be agree with me that we need a inheritance here. But for maybe we don't need inheritance for other requirements, but for our requirements we have like specific things, like if a vehicle can fit in a spot, or that's why we have fit in spots. We have another requirement of multiple spots. So for those kind of thing, I found this inheritance is required or will be useful. So I have here a strict class vehicle which has license plate, spot required, and a list of spots. And it has the function clear spots, assign spot, and can fit in spot. So can fit in spot is abstract. Motorcycle extend vehicle, car extend vehicle, and bus extend vehicle. So I think now we have a bird view of the design, like what will be our classes, and so just try to remember this thing when we go to the code, or we can come back and see this design. So let's start the code. Um So this is our code, and we can start with this vehicle. So the abstract class vehicle has license plate, stop required, and clear spots, assign spots, those functionality. And this is the abstract method. Um, so motorcycle extends vehicle, and it can fit in any spot. In large spot, compact spot, or motorcycle spot. But there is a question like, is it this is the wastage of spot, right? If I put a motorcycle on large spot, then it's a wastage of spot unless we have lots of spots, unless we are running out of spots. So the requirement could be like that. We need to first try a motorcycle to fit in motorcycle spot. If no motorcycle spot is available, then we can try to put it on the any compact spot. If no compact spot, then we can try to put it on a large spot. So maybe we can use chain of responsibility design pattern for doing that, to construct different chain. Like what is the next? Like the compact spot, motorcycle spot. Next would be compact spot, and the next would be large spot. But I haven't implemented this way because there is a limitations at what we can implement. But there is a possibility, or I would say when there is a single lot, just one floor, then we can have multiple entry, and we can keep the spots in a priority queue, which is a mean heap, and which is based on the distance from the entries. And for all the entries, we can have priority queues, and then when you enter from a gate, you get the next spot from the queue for your kind of vehicle. So that can be done. This is another design, but our use cases is different. So let's go back to our bus. Bus is extending vehicle, and it can take large spot only. And for car, it can take compact spot, or it can take large spot. So for both of them, it is fine. Let's look at the configuration. So we are maintaining a atomic integer ticket number to maintain the ticket number and auto increment it. And this is the level 1 layout. So we are passing it as configuration, level 2 layout, level 3 layout. And then there is a parking rate configuration here. So for motorcycle, hourly rate is $5. For compact, hourly rate is $8, and large hourly rate is $10. So it's in the configuration class instead of the parking lot, because it has this hard-coded value. So it more fits on the configuration class, I think. And number of levels. So in a parking lot, how many levels we'll have? So we are now creating only one object of parking lot with three levels. So this is our level layout, and then we can go on spot. What we have in our spot, the same thing that we have discussed in the UML diagram, class diagram. So the spot has a create spot. So it can create an object of spot based on the type we provide. If we provide motorcycle M, it will create a motorcycle object. For C, a compact object, compact spot, and for L, it will create a large spot. And there is a free spot, reserved spot. What you can see that is occupied is making a true, is assigning the vehicle, and is assigning a start time for reserved spot. And this is the enum spot type that we have inside a spot that we are using everywhere. We have three different type of spot. And let's go to level. So as I said, there are levels. We have rows. So we have rows, right? This is row one, row two, row three. So for level two, we have four row, and for level three, we have five row. And what you can see that these rows can have multiple spots. Not necessarily they will have same type of spots or same number of spots, because our building can be of different shape, right? So, and we want to utilize the spots. So we are not considering the building as a square building, and everything is squared. So here we are creating the spots and adding it in the rows for level. These um, and there is add a spot, assign spots. For assign spots, what we are doing, we are going to do find available spots. So this is our find available spots. So it is going through all the rows and checking if the spot is not occupied, and if the vehicle we are passing fit in the spot. Now, then it's checking that how many spots we require. If it is just one spot required, we can return the spot here. But if it requires multiple spot like bus, then it is actually finding start. It is going taking this start index as a index, and then spot index as an index, and then it is going to the adding the number. If there is five consecutive index, it is adding that number spot required. And then it is using this function is consecutive free spots exist. So it is basically checking if all the spots after this spot, if we have five spots, those are not occupied, and those are the similar kind of spot that the vehicle need. In our case, for bus we need large spot, so it is basically checking if it is large spot and if it is not occupied. If we have such five spot, it will return true. So when it return true find available spots, then we are getting actually we start time, and all these spots, right? We are looping through all these spots and reserving all these spots for this vehicle. So in our case, five spots will be reserved for the bus or assigned for the bus. So this is our assigned spot, and a print layout for vehicle. So I'll show you when I run it. So we need to see at any time that what is the layout of a level, and create a spots for level. So this one basically takes a level layout like the layout we had, and from the level layout it creates the spots for each level. So level layout is here in our configuration. These are level layouts. So passing these two-dimensional character array, it creates the level. So now that we are done with level, we can see the ticket. So what is a parking ticket? A parking ticket, this is the auto increment of the ticket number. So it's not provided, but it's generated. It increments the one in config. It's an atomic integer, so it's thread safe. And this is for calculation amount. And calculate amount is basically parking duration in minutes, right? It has a start time. When it's checkout time, it has the end time. So it finds the park minutes, duration in minutes, and from the duration in minutes is converted to hour, because we have hourly rate. And then for each of the spot it finds the hourly rate and multiply it by duration, and sum it up to amount to calculate the charges. So if a bus needs 5 spots, so it will be charged for all 5 spots. And this print ticket, it print details about the ticket. So this is our ticket class, and I think I have gone through all the classes except the one that we need to test. So now that we have the parking lot, we can see how we can test this parking lot. We create the parking lot object with a number of levels. So in our case, we have three number of levels, and parking lot ID is one. And then we create level one, and we create spots for level one by passing the layout for level one, and we add level one in the parking lot. The same thing we do for level two and level three. So now vehicle, say we want to park a car, so we provide the license plate, and for car we need just one spot. We call the assigned spots that internally call park vehicle, that internally call find available spots. If available spots is there, it park the vehicle and assign ticket. So we print the ticket here. So the same thing we'll be doing for motorcycle, and the same thing we'll be doing for bus. And here is a delay. I have this delay because at least there is 1 minute to find the amount for or charge, right? If the minute is zero, then there is no charge. So what we can do, we can run this and see. Surely there will be a delay here. So it is running. Okay. So it is waiting here actually. So this is our layout, level one layout. We have like this, level two layout, level three layout, and this is our ticket number one, license plate C1. Start time this, end time is null, is paid false, spot one, amount zero. We don't know the amount yet. The same thing for ticket number two. We actually after assigning car, we park a motorcycle, and we park a bus as well. So we will see here the spot IDs, right? So this is interesting. So let's see where the car was parked. The car was parked as spot one. So this is the largest spot it find, and it knows that a car can fit in this spot. So spots one was given to the car license plate C1. Now this one is a motorcycle M1, and it found this spot too because motorcycle can fit in large spot, and this is the nearest spot on level one. It was assigned this one, and third one is a bus. So for bus, let's see how it finds a spot. It found 21, 29, 30, 31, 32. So it needs actually 5 consecutive spots. So this is actually our 5 consecutive spots. There were no large spot here. So it found 29, 30, 31, 32, uh, up to yes, 28 to 32. Sorry, so 28 to 32 spot it found. So if there was no large spot here, it would go to the next level and try to assign it here. If no, it will go to the next level and try to assign it here. So this is how we are parking bus. So our delay is gone now. Actually, what our output came, we are checking out a vehicle with ticket number three. That means the bus, we are checking it out, and spot taken. Okay, size of spot taken after clearing the spots. Ticket number three, and vehicle license plate B1. Okay, there is a thing, but I didn't print out maybe the values. Size of spot taken, and start time is here, end time here is paid false, and it calculated the amount, which is 83 cents for 1 minute of parking. So, real life will have different configuration. Of course, will not be charging for a minute. Maybe any car is parked will be charged at least for half an hour if it wants to check out. So I think that's the implementation part here. If we go back to the browser again, so we have some. So this is springsoft.com, where my website, where I have also published the code and the GitHub link for this one. So you can also go here and see the diagram and find the assumptions and find everything over there. And you can also get the GitHub link from here. So I have uploaded the code in object-oriented design repository. It's parking lot. So you have the code here. So yeah, I hope you enjoyed it. If not, you can let me know in comments. You can provide the suggestions so that I can try to improve. So thank you.